Black holes are among the strangest, most exotic, and perhaps most misunderstood objects in the universe. This video aims to answer some of the big questions, such as what is a black hole, how big are black holes, how do black holes form, could a black hole destroy Earth, and many more. You might be interested to know. Most people think of a black hole as a voracious whirlpool in space, sucking down everything around it. But that's not really true. So, what exactly is a black hole? First, it's not really a hole. The basic idea of a black hole is simply an object or a region in space where gravity would eventually become so strong that nothing, not even radiation, moving at the speed of light could escape from it. Albert Einstein's 1915 general theory of relativity deals largely with the effects of gravity and, in essence, predicts the existence of black holes and singularities. Einstein hypothesized that gravity is a direct result of mass distorting space. He argued that space behaves like an invisible fabric with an elastic quality. Celestial bodies interact with this fabric of space-time, appearing to create depressions, which is termed gravity wells, and drawing nearby objects into orbit around them. Based on this principle, the more massive a body is in space, the deeper the gravity well it will create. Therefore, an object with enormous mass but infinitely small size would create a bottomless pit, which is the topic of discussion today, a black hole. The next big question is, how do black holes form? The traditional recipe to make a black hole needs a single ingredient, a very massive star at the end of its life. The life of a star is a continuous struggle between gravity and pressure radiation. Gravity compresses the star while the radiation due to nuclear fusion pushes its matter outwards. When the fuel is exhausted, the star stops burning. If the star doesn't have much mass, like our own sun, it will become fainter, cooling down as a white dwarf. However, if its initial mass is about 8 times that of the sun, it will collapse, bounce back, and detonate in a supernova. Neutron stars form in this way, and if the original mass exceeds about 25 solar masses, at the end nothing can counteract gravity, and the whole mass is squeezed into a point of zero volume and infinite density. This point is called a singularity. Hence, what is left at the explosive end of the life of a very massive star is a singularity surrounded by an event horizon, an object we know as a black hole. There are a couple of different ways to conceptualize how big something is. The first is an object's mass, that is how much matter it contains, and the second is its volume, or how much space it takes up. One of the fundamental questions people have is, how big can a black hole be? Black holes come in many sizes, and their size depends on how much material is in them. It can be as light as a feather or as heavy as a few billion suns. Some are the remains of a giant star which collapsed. These type of black holes are only a few miles across. Black holes have also been discovered in the centers of some galaxies. These black holes are very large and contain the same amount of material as 100 million or more suns. These type of black holes are several million miles across. A typical stellar mass black hole would have a radius of 30 kilometers, and a supermassive black hole would have a radius of 3 million kilometers. The biggest myth about black holes is that they suck. Do you also fear that a black hole will suck Earth in the future? Don't worry, just relax. A black hole is not like a vacuum, sucking in everything nearby. Earth will not fall into a black hole because no black hole is close enough to the solar system for Earth to do that. Black holes aren't the cosmic vacuum cleaners they are rumored to be. But could you still fall into one? What would happen to you? The answer to that question depends on whom you ask. Thanks to quantum gravity. Once you reach the event horizon, there is no longer any hope for you. You cannot slam on your rockets and try to break free. You cannot even go into an orbit and just hang around until someone can rescue you. There is no amount of rocket energy or force that will let you leave, because to do so you will have to travel faster than the speed of light. All you can do is watch your clock, which will tell you about the next most important event in your life, your death. Your next destination is the singularity. Space is a pretty dark place. Nothing is darker than a black hole. If black holes are black, how can we find them? Black holes are detected as surrounding material like gas is funneled by the force of gravity into a disk around the black hole. The gas molecules in the disk swirl around the black hole so fast that they heat up and emit X-rays. These X-rays can be detected from Earth. Black holes can also be detected by watching for motions of stars near the black hole. There is a very large black hole at the center of our Milky Way galaxy. It has a mass of about 3 million suns and is very far from Earth, at a distance of about 24,000 light years. Huge black holes are thought to occur naturally at the center of most large galaxies, and many have already been detected. The black hole, which lies at the center of our galaxy, is much too far away to be of any danger to Earth. In 1973, Stephen Hawking deduced that the rotating black hole can evaporate and lose mass, thanks to the quantum mechanical properties of empty space. Pairs of electrons and anti-electrons are constantly appearing and disappearing in space. If this happens near the event horizon, one particle escapes while the other carries negative mass into the black hole. This causes the black hole to lose mass. The first object considered to be a black hole is Cygnus X1. The question is, how do we study black holes? Scientists are learning about black holes using a spacecraft like the Chandra X-ray Observatory, the Swift satellite, and the Fermi Gamma Ray Space Telescope. Fermi launched in 2008 and is observing gamma rays, the most energetic form of light, in search of supermassive black holes and other astronomical phenomena. A spacecraft like these helps scientists answer questions about the origin, evolution, and destiny of the universe. I hope you like this video. Please like and share my videos and subscribe my channel, and don't forget to hit the bell icon. Thank you for watching Competitive Physics.